Hi you guys, I wanted to show you a real quick video on how you can make those graphs. This is one way to do the graphs, maybe the easiest way. So I'm starting in Excel here with a spreadsheet. I've got my time that I measured for all the distances that my rolling object was at. So this is kind of the data that you've collected there. You could present that data in the report that you're creating if you like. I can create a graph of this, of course, by just selecting that and choosing charts and choosing an XY scatter with no line on it. And there you can see that my data has been graphed. But we're actually going to be doing a little bit more with it. We also, in that graph, want to see what we expected to have for a distance rather than just the measured distance. So to do that, you're going to have to calculate some theoretical distances for these same times that have been traveled based on the acceleration of your guy. So I'm looking at my, I'm using A is equal to 5/7 g sine theta. I'm going to be doing some calculations with that. You can see that I've had to convert the degrees to radians because the Excel formula or the Excel function sine only works in radians. And I've just written here, this is just text here. This is not actually doing the calculation. If you want to do a calculation in Excel, you have to say equals and then type in the thing that you want to calculate. So 5/7 times 9.8 times sine of the radians, and 10 is my value there. When I do that, it's actually calculating then the acceleration. So this is a value here, and it's stored in cell D2. So I can use that in my calculation if I like. One of the things I can do here is I can say, well, what's my expected distance after a certain amount of time has passed? So I'm going to put in another formula here where x final is equal to x initial, 0, plus vi times t, where v initial was 0. And if I'm going to grab the time here, of course it's 0. I'm going to click on that. That's going to give me the time there. So that's v initial times time. And then plus 1/2, or 0.5, times a, the acceleration, which is this. So I'm going to click on that, times t squared. So I'll click on this again and make that a squared there. So I've got a formula that's going to calculate. It's a kinematics formula that's going to calculate based on the values in there. And it's kind of cool. There's going to be some amazing stuff that we're going to see here in a second. So I hit enter and it finds out that my theoretical distance is 0. That's not too bad. If I fill down here, there's a couple things I want to show you. If I fill down here, it's not going to give me any values here. And that's interesting. I wonder why that is. Because I should be having some different times here. If I fill all the way down here, something that's interesting, if you look at this, you can see the formula up here. It's equal to 0 plus 0 times whatever A5 is. A5 is 0.58. That's VIT plus. Okay, so that's correct. That formula is working. This should be 1/2 times the acceleration t squared. But the acceleration, notice the acceleration listed here is d4. That's incorrect. D4, it should be, the acceleration should be up here in D2. What's going on with that? Well, so this is a little bit of Excel theory, spreadsheet theory. When you type in a cell, when you enter a cell, for instance, in this first one up here, when I typed in the cell up here, you can see that I did A3 because that's where the 0 was for the time. If we go down here and look at what's happening in C4, notice that Excel has automatically adjusted to choose the time in A4, the time that goes with that. So Excel is smart enough to go down and choose the next line to go with all these lines here. What it doesn't know is the fact that this acceleration here should be used for everything. That acceleration needs to be used for all of these. If I fill down and then look at this guy here, you can see it's gone down for my acceleration. It's looking for something in D3. Well, there's no acceleration listed in D3. The acceleration is always going to be in D2. There's a way you can fix that. What you do is when you do the first formula there, instead of typing D2, you do $D, $2. And that'll anchor that so that when we fill down, it will always use that cell. So let me fill down now and see if this works the way I think it should. It looks like I'm getting some numbers there, and if I click on one of those, you can see it's still using D2. It's still using D2 for all these. So that cell has been anchored while we are correctly using the different times here. So all that is to get your data set up. Once you've got that set up, it's actually pretty easy to do. You select the data you're going to graph. Time will go on the x-axis. These two distances will both go on the y-axis. So we'll get two curves, as you might expect here. The red one here, it looks like, is our predicted data. The blue one is our experimental data. And what I'm going to do then is choose a best fit line for our blue data. So I'm going to control click or right click on that and add a trend line. Starts out with a linear. You know we need to convert it to a second order polynomial, and we also want to see the equation on there. So we'll display that equation, and that's our experimental data. That's kind of nice. We also want to draw a line for the red data here. This red data, these aren't actual data points. We need to keep that in mind. These aren't data points. So I'm actually going to create a trend line for those guys. And maybe I'll even format that trend line a little bit here. I'm going to, I don't know, make sure it's a second order polynomial first of all, and then I'll make the line a nice red color, and I'm going to jack up the weight on that a little bit so it's a little bit more prominent. I also want to make sure I don't have those guys there, so I'm going to right click on one of those markers there and choose Format Data Series. And for the marker style there, I'm going to change the marker to no marker. So now you can see when I look at this, I've really got my data with a trend line and the expected data or theoretical data with no data points, and that's as it should be. So that's a pretty good looking graph. There's some other things I need to do. Of course, I need to go up to the formatting for all these guys and add titles for this, add labels for the axes, and you can figure out where all that is if you look around up here. Good luck. I hope that helps.